Hi, welcome to the course on classical physics. We will continue with our lectures on kinematics. So this is part 2 of my lecture. This is about problem solving. Let's look at a few questions and we'll try to analyze how we are applying the theory that we have learned. Right? So the first question is this. Two particles move in a region of downwards gravity g. They begin at the same location with initial velocities v1 and v2 to the left and right respectively. So basically, let's say these two particles are here. One of them begins with V1 and V2 to the left, V1 to the left, and one of them with V2 to the right, respectively, right? Now, there is downward G in this region. Find the distance between the particles when their velocities are perpendicular to each other. So obviously, this is a question of projectile motion. So as this begins like this, it will start falling as well. So the trajectory of this particle will be somewhat like this, right? And similarly for this particle, it will start falling as well while it is going ahead. So the trajectory will be like this. Now you have to find the distance between the particles when their velocities are perpendicular to each other. So this is your velocity at an arbitrary moment, and this is your velocity at another moment. So when will these two velocity vectors v1 dash and v2 dash become perpendicular to each other, right? So let's see how we will go about it. Let's call this point as the origin, this point where they start off with. So initial velocity of the particles is what? It is minus v1 I cap, right? And plus v2 I cap, right? These are the possible velocities initially. This is minus v1, this is plus v2, right? Now, as time passes, both the particles will acquire a downward velocity due to gravity, because gravity is pulling them down. There will be a Vy is equal to u is 0. Initially, they had 0 vertical velocity, 0 plus gt. However, this Vy is actually in the downward direction. So they will acquire a minus gt j cap and a minus gt j cap, right? As time passes, this is the x component and this is the y component of the velocity. And this is the x component and this is the y component of the velocities for the other particle, right? So if we write the velocity vector in terms of vector components, so we can say first particle will be minus v1 I cap minus gt j cap, and second particle will be plus v2 I cap and minus gt j cap, right? Why are we keeping the horizontal components constant? Because there is no force in the horizontal direction on the particles. So there is no acceleration in the particles in this direction or this direction. So the velocities in those directions remain constant, right? So we have to find the time when these two velocities are perpendicular to each other. And there is an easy way to do that. We know about dot product of two vectors. If two velocities are perpendicular to each other, then their dot product must be equal to 0. So let's say that v1 dot v2 is equal to 0. So that means minus v1 I cap minus gt j cap dot product with v2 I cap minus gt j cap must be equal to 0. Now dot product will be calculated in this way: minus v1 v2, the components I components are multiplied and j components are multiplied, plus g square t square is equal to 0. Therefore we get v1 v2 is equal to g square t square, and therefore time is equal to simply v1 v2 root over by g. So time when this happens is root over v1 v2 by g. Now what is the distance that they will have at that moment, right? So think about it. Since their vertical velocities are in sync, they are equal vertical velocities, so they will fall equal distance vertically downward, right? Because your distance in the vertically downward direction will be 0 plus half ay into t square, which is half gt square, right? So both the particles, while they move, will fall down by an equal distance. So there will be no distance between them in the y direction. However, this is the distance between them, the x direction distance, right? So since one of them is going at v1 like this and one of them is going at v2 like this, the relative velocity between them is simply v1 plus v2, right? The relative velocities get added. The total relative velocity by which they are separating from each other is v1 plus v2, and the total time is root over v1 v2 by g. So the total separation finally at that instant will be simply v1 plus v2 multiplied by root v1 v2 by g. So that is the answer. The key point in this question is don't get scared if someone says velocities are perpendicular to each other. Some weird sort of condition could be imposed in the question, but you don't have to worry about it. Just write vectors and say that the vectors must have dot product 0, right? So we wrote our velocity vectors and just solved it after that. We got the time from there, right? Okay, let's move on to the next one. The next one is quite an interesting question. It says a particle moves with constant acceleration, and some data is given. Constant acceleration and data that is given is t is equal to 0 second. The speed of the particle was equal to v. T is equal to 1 second. Speed was equal to v by 2. T is equal to 2 seconds. Speed was equal to v by 4. And now they are asking t is equal to 3 seconds. What is the speed? So don't get fooled by this. This is actually a little tricky because this is speed, right? So speed is actually the modulus of your velocity. So let's start off by saying at t is equal to 0 seconds, velocity of the particle, velocity was equal to v vector, right? We know that mod v is equal to v, right? Now what happens, let's say the acceleration vector is a, right? So what happens at t is equal to 1 seconds? So v final should be equal to v minus v plus at, right? So v plus a into 1 seconds. So therefore velocity at 1 second is equal to v plus a. Therefore speed at 1 second is the modulus of velocity, is equal to mod of v 1 second is equal to mod of v plus a, or basically the length of this vector v plus a, and that is given in the question, and that is equal to v. So the first equation that we have is v plus a mod is equal to v. Now similarly, in a similar manner, you can say that speed at 2 seconds would be mod of v at 2 seconds, which is equal to mod of v plus 2a, right, is equal to v by 2. So your second equation becomes mod of v plus 2a is equal to v by 2, and your third equation becomes mod of no, actually speed at 1 second was v by 2 and speed at 2 seconds was v by 4. So these are your two equations. I made a slight silly mistake here. So now what do you have to do? Now you have to find out mod of v plus 3a, right, is what, correct? So how do you solve these two equations to find out this thing, right? So actually this is just an operation on vectors, so you need to be comfortable with that. What I will suggest is if you have v dot v, remember that that is equal to mod v whole square, right? So if I have equations like this, v plus a mod is equal to v by 2, I can just take mod of v plus a dot v plus a, right, which is equal to v square by 4, which is equal to mod of v plus a whole square, and that will be equal to dot product of these two vectors. So it will be basically root over v square plus 2a dot v plus a square whole square is equal to v square by 4. So what I want to say is basically mod of any vector or any sum of two vectors can be written as root over dot product of v plus a dot v plus a, and that turns out to be v square plus a square plus 2a dot v. So keep this in mind, that will help you. So in this case, our equation becomes v square plus a square plus 2a dot v is equal to v square by 4. The equation is a square plus 2a dot v is equal to minus 3v square by 4. This is my first equation. The second equation will come when you simplify v plus 2a mod is equal to v by 4. And again, squaring it in a similar fashion, you will get the equation v square plus 4a square plus 4a dot v is equal to v square by 16. And you can simplify this a little bit and you get the equation 4a square plus 4a dot v is equal to minus 15 by 16 v square. This is your second equation. Now in these two equations, the variables for us are a square and a dot v. Here also there is a square and a dot v. So I will leave it to you. You can easily solve it to find a dot v and a square. This is two equations in two unknowns. So when you solve, you get a square value as 9 by 32 v square and a dot v value as minus 33 by 16 v square. So suppose we got these values, right? How do you find the answer to the question? The speed of the particle at 3 seconds was being asked. So that is just this, which is just equal to v square plus 9a square plus 6a dot v. So now once you put in the values that we have just discovered, we have discovered a square is equal to 9 by 32 v square and a dot v is equal to minus 33 by 64 v square. If you put in these values in this, you will get the final answer, which will be root 7 by 4v. So notice that it didn't follow the pattern that you were expecting. Speed at 1 second was v by 2, speed at 2 seconds by v was v by 4, but speed at 3 seconds is root 7 by 4v, right? So it is not some obvious question. You have to employ vectors, you have to do mod of those vectors to get the speed expressions, and then it is about solving two equations in two unknowns, right? So I hope you understood how we are doing it. You should be able to handle these vector operations. V dot v will be equal to mod of v whole square. So therefore mod of v can be written as root over v dot v. That is what we are doing. That is what we are doing here, right? Okay, let's move on to the next question. Question number 3. It says a particle is thrown from level ground, is projected basically from level ground at a fixed u, but a variable angle alpha, right? There are two possible paths which result in the same range r, okay. Let the time taken by the paths by these paths be t1 and t2. You have to find t1, t2, right? So let's think about what we will do here. So there is one possible path and there is another possible path, right? They both result in the same range, right? Range is fixed. So one time you're launching with some angle alpha, one time you're launching with some angle beta, right? And both times the range is the same. So now we know range comes in when you're projecting particles on the level plane. Range comes by doing 2v sine theta by g, which is time of flight. In this case, let's call it 2v sine theta by g multiplied by horizontal velocity, which is v cos theta. So this becomes basically range is equal to v square sine 2 theta by g, right? In this case, first time you project it, let's say t1 time, and this is t2 time in this path. So one range would be r1 would be v square sine 2 alpha by g, and r2 would be v square sine 2 beta by g. Now if r1 is equal to r2 in this case, as the problem claims, You will have basically sine 2 alpha is equal to sine 2 beta, right? Now this can happen in multiple situations. The general solution is 2 alpha is equal to n pi plus minus 1 power n into 2 beta. So this is the general solution of the trigonometric equation. Or you can think of it like this, that 2 alpha could be 2 beta, but that is not possible because they have different angle of projection. So this is not possible. What else could happen? Sine 2 alpha could be equal to sine of pi minus 2 beta, right? Because sine pi minus 2 beta is same as sine 2 beta. So because we know sine 180 minus theta is equal to sine theta. So therefore, you could have 2 alpha is equal to pi minus 2 beta, which implies that 2 alpha plus 2 beta is equal to pi, or basically alpha plus beta is equal to pi by 2, right? So therefore, beta is equal to pi by 2 minus alpha. So these alpha and beta angles are complementary angles. As long as they add up to 90 degree, they will result in two different paths whose range is the same, right? So once we have that, let's find out T1 and T2. So time of flight was actually this expression. So first time of flight is 2v sine alpha by g, and second time of flight is 2v sine beta by g. But sine beta is equal to cos alpha here because they are complementary. So when you multiply this, it becomes 2 into v square sine 2 alpha by g. And that is actually equal to, this is g square. And that this part becomes equal to range. So 2r by g. Your answer should come out to be 2r by g. This is a fairly straightforward question. There is nothing weird about it. You just have to figure out what angles are possible when you will have equal range for two different paths, right? Okay, let's look at another projectile problem. This is slightly different. This is basically, there is a vertical circle here, and you are launching something from this point. This is radius r, and you are supposed to launch from this point in such a way that the projectile touches the top of the circle here, but doesn't collide with it anywhere else. And the projectile is crossing over and coming to this side. It only touches here, touches on the top, but does not collide with the circle anywhere else. But doesn't collide with the circle anywhere else. Anywhere else. Now, what you have to do is, it has been thrown with speed v. It has been thrown with speed v. You have to find the maximum radius r of the circle so that there is no collision. So that there is no collision, except there might be contact at the topmost point. There is no collision. Okay, so let's think about this problem. So if it just touches at the vertical point, so its height, its maximum height, this is symmetrical projectile, and the maximum height basically here is equal to 2r, right? Maximum height is equal to 2r. So we can figure out the vertical velocity from there. So final vertical velocity here must be 0. Vertical velocity must be 0 here. That means Vy square is equal to u square, V initial square minus 2 into g into 2r, right? So therefore, you have V initial, this is final is 0, is equal to Vy square minus, my variables are wrong. What I'm saying is V final square is equal to u square minus 2 into 2gs. So 2 into g into 2r. This is your vertical equation. And this is 0. So it is equal to u square minus 4gr. So this implies that your u square was 4gr. And what is u? U is the initial vertical velocity, right? That is equal to 4gr. So therefore, initial velocity v square can be written as vx square plus vy square, right? So therefore, vx square is equal to v square minus 4gr. The question has specified that the particle was launched with speed v. So we are writing the x component of the velocity in terms of the speed and the vertical component of it, right? So v square minus 4gr. Now, how do you think we will write the condition that the particle doesn't collide with the circle, right? Okay, so it is touching the circle here, the projectile, but it is not colliding with the circle anywhere else, right? So think about the projectile coming from this side to this side. Since this path is symmetrical to this path, so we can just focus our attention from here to here, right? That will be slightly easier for us. So let's say the particle is here. It has just horizontal velocity Vx right now. That horizontal velocity remains constant. Initial horizontal is same as this horizontal. So it has horizontal velocity right now. It has vertical velocity 0, and now it is going ahead. So we have to ensure that it doesn't collide with the circle. So we have to say that if it doesn't collide, the distance of the particle at any point t, at any time t, this distance must be greater than r, right? The distance pc must be greater than the radius of the circle for no collision, right? Then only it doesn't collide. So let's track the position of the particle p after it goes from this side, and let's find out what is its distance from the center c, right? So if you look at the velocity of the particle at some point t after the topmost point, from here onwards, let's start counting time. So we'll say velocity of the particle or distance covered by the particle would be basically x is equal to vx into t, and y will be equal to 0 minus half gt square, minus half gt square. So basically it will be going down by some y and it will be going forward by some x, right? This is your location, right? Now, can we now calculate the distance? Yes, we can. So the distance from the center would be distance square is equal to x square, there is no confusion, vxt whole square plus this vertical distance. This vertical distance is actually r minus y, right? Correct. So it will be basically r minus half gt square whole square, right? Correct. R minus half gt square whole square. This is going to be your distance, no? If you are a little confused, let's draw a separate figure and think about it. The particle starts moving like this with Vx and vertical velocity is 0. But it is falling under gravity, so it will come down by some y amount, which is equal to half gt square. And it will go forward by some x amount, which is equal to vxt. So distance from this point, this distance basically, right? This distance will be equal to this distance, which is r minus y, and this distance, which is vxt whole square. So my d square will be equal to vxt whole square plus r minus y whole square. So that is what I am writing. Vx square is equal to vx square t square plus r minus y is half gt square whole square, right? So this distance, this d square must be greater than r square for no collision, to happen, right? Great. And we already know that vx square is equal to v square minus 4gr, right? V square was the initial speed and this was the condition on the vx square, right? So simplifying this a little bit, let's write the inequality vx square t square plus r square plus 1 by 4 g square t power 4 minus 2 into r into half. So r g t square is greater than r square. This is the condition. After expanding the square, r square gets cancelled, and what we have is vx square t square plus 1 by 4 g square t power 4 minus gr t square is greater than 0. 1 t square can get cancelled here. So what we will get is basically the condition the condition that we get then is Vx square plus 1 by 4 g square minus gr 1 by 4 g square t square, actually 1 t square got cancelled, minus gr is greater than 0, right? So 1 by 4 g square t square plus vx square minus gr is greater than 0. Now the particle should never collide the uh, with the sphere, right? The particle has to never collide with the sphere. So that means that for any t, it should not collide. So for any t, the distance should be greater than r. So this part is positive. We have to ensure this part is also positive, because if we don't, then there could be some t at which this is negative enough to make it whole thing negative, right? So I will ensure this by having that Vx square minus gr is itself greater than 0. And now I can write it as V square minus 4gr minus gr is greater than 0, which gives you the condition V square is greater than 5gr. So that tells you that r should be less than V square by 5g. So that is the condition on the radius, so that the particle that is projected with a speed v just touches the top point of the circle and doesn't collide with the circle anywhere else and crosses over, right? We could have solved this in a much easier way if we had utilized the concept of circular motion and centripetal acceleration v square by r. We could have just taken the topmost point. We could have taken radius of curvature should be greater than the r of the circle. So radius of curvature at the topmost point would have given you Vx square by r. Radius of curvature should be greater than centripetal acceleration would have been Vx square by r, and that would be greater than the r of the circle, radius of curvature. So that would immediately solve the question, because Vx square by g would come as greater than r. So Vx square would come as greater than gr, which is what we got eventually, right? But I have not taught those concepts before, so I'm not using that. We use the simple idea that for the circle to not, the particle to not collide with the circle, it should always have distance greater than r from the center of the circle. Let's go to the next one. The next question is about relative velocities. Let's look at this. Two planes. One plane is coming like this. It has initial velocity v1 is equal to 800 kilometer per hour. You might have seen this type of question before. Another plane has initial velocity 600 kilometer per hour, like this. And now they see each other, and they are always going to approach each other, right? And right now this distance is 20 kilometer, and this distance is also 20 kilometer. Okay, so they are always going to, these planes are flying like this, and then they notice each other, and they are always going to approach each other. Okay, so approach each other means what? This plane will direct itself towards this, so it will turn, basically it will direct it towards this, and similarly this plane will direct it towards it, and eventually what will happen is they will pass by, or they will meet, or something like that, right? So what we have to answer basically is, at a certain moment in time, both trajectories are perpendicular to each other. Both trajectories are perpendicular to each other at a certain moment in time, and and 20 kilometer from the point of intersection. So this is the initial point. 20 kilometer from point of intersection. So right now what the question is saying is that at this moment, the trajectories of the planes are perpendicular to each other and 20 kilometers from this point, right? Now we have to find the minimum distance between the planes if they now start approaching each other. Find the minimum distance between the planes. Okay. So in this question, it is convenient always to put yourself in the frame of one of the planes. So if you put yourself in the frame of this plane, you will notice that your initial velocity of this plane will become now 800 like this and 600 like this, because you are in the frame of this plane. So that initial velocity has a particular direction, right? That initial velocity will sum up to be a velocity of 8 square plus 6 square, which is 10 square. So 1000 kilometer per hour, right? 1000 kilometer per hour in a particular direction, right? And this person is stationary here. This person is stationary here, and it will go over like this, right? Now you have to find the shortest distance. The shortest distance between the two planes will be when the line joining the plane and the person stationary here, the second plane stationary here, is perpendicular to the velocity of that first plane, right? Basically, what has happened in this question, this person is stationary here with the plane, and this plane is coming like this, and you have to find the shortest distance, right? So first of all, you figure out where it meets like this, where it meets, and draw this diagram basically. So if you think about it, this is 1000 kilometer per hour, and the time where it intersects here, we have to find information about this point. How? So 800 kilometer per hour was its x velocity, right? And it has covered basically 20 kilometer in x, right? So the time taken to do that would be 20 by 800, right? 20 by 800 hours. In that much time, you will reach this point. So how far below have you come? How far below? So you will go 600 kilometer per hour into that much time. So 600 into 20 by 800, which is equal to 3 by 4. So that is 15 kilometer. So basically you have gone 15 kilometer down. That is the point of intersection. So clearly this is 5 kilometer from this point, right? 5 kilometer from this point. And now you can see that this right angle triangle is similar to this right angle triangle, right? Correct? These are similar triangles, this one and this one. So since it is a similar triangle, so angle opposite the 90 degree is 5 here. Angle opposite the 90 degree would be this one. So this side and this side would be similar. And similarly, what you can figure out now is that this angle and this angle are matching. So if you have sine theta here, right, or actually you have tan theta here, right? Tan theta is 800 by 20 by 15. Tan theta is 4 by 3 here. 4 by 3 is equal to tan theta. So similarly, you should have tan theta is equal to 4 by 3 here. And since this is 5 kilometer, so tan theta would be 4 would be this and 3 would be this. So the minimum distance would be basically 4. 4 kilometer is the minimum distance by similar triangles, and by the fact that since I have made this at rest, the plane is just basically coming like this and intersecting somewhere, because it has acquired a 600 down also, right? And this triangle that is there is perpendicular to this triangle, is similar to this triangle, this right angle triangle and this right angle triangle. So since this came out to be a 3 4 5 triangle, this will also be a 3 4 5 triangle. And we have already found that this is 5, because how much time does it take for the plane to reach this point? It takes 20 by 800 hours. And in that much time, you will go 20 by 800 into 600 kilometers, which will be 15, right? So 5 kilometers is left. So the fairly straightforward question, once you got the idea. I will do one last question, which will be about range and range of a projectile on an inclined plane. So the question is very standard, and sometimes people struggle with this. So I'll just solve this for you. So if this is the angle theta and you launch a projectile with an angle alpha, right? Angle alpha. Now the question is asking you basically maximum range. And let's say this is velocity v. Maximum range of the projectile along the inclined plane. Along the inclined plane. And how do you go about finding it, right? So keep in mind that this is an inclined projectile. So I am free to choose my coordinate axis like this. This is my y-axis and this is my x-axis, right? So let's draw the components of your velocity. Your initial velocity has one component v sine alpha like this and one component v cos alpha like this, right? And while it is in motion, gravity will be vertically downward. Let's draw the components of gravity as well. This is 90 minus theta. So this is theta. So gravity will have one component g cos theta like this and one component g sin theta like this, right? So now, if you think about it, this is a typical projectile motion now in your y and x directions, but the only difference is now g is no longer g, it is g cos theta, and there is an x acceleration of g sin theta also. And your initial vertical velocity was v sin alpha, and this velocity was v cos alpha. Everything is same as the original projectile situation, right? So time of flight would be simply 2 into vertical velocity, which is v sine alpha, by downward vertical acceleration, so g cos theta. So range basically should be simply time of flight. Okay, actually range will be different because there is an x acceleration in the backward direction also. X would be initial velocity, which is v cos alpha into time of flight, 2v sine alpha by g cos theta, minus half into gt square. Half into g sine theta is the x acceleration backward into t square. So 4v square sine square alpha by g square cos square theta, right? So this is the expression that you need to simplify, right, to get the range expression. So I'll just get some space here. If you have doubts about the figure, please refer to this figure and pause the video and go back and draw it yourself and convince yourself that this should be my x, right? Now let's see how to simplify this. Okay, so this is my range. So x is becoming v square, and this is v square 2v square sine alpha cos alpha by g cos theta, minus this is 2v square, and g comes in the denominator, sine theta sine square alpha by g cos square theta, right? Okay, so if you take common here, 2v square by g cos theta common, so you will get what? You will get sine alpha cos alpha minus sine theta sine square alpha by cos theta, right? Correct. So actually we could have taken a sine alpha common also. So let's take sine alpha common as well. 2v square sine alpha by cos theta, g cos theta. And now you have cos alpha minus sine theta sine alpha by cos theta. So that becomes cos alpha minus sine theta sine alpha by cos theta. And you realize that this will become 2v square sine alpha by g cos square theta. And this is cos alpha cos theta minus sine alpha sin theta, which is cos of theta plus alpha, right? That is just cos of theta plus alpha. So that is my range. My range expression has come out like this. Range is equal to 2v square by g cos square theta multiplied by sine alpha cos of theta plus alpha. Now this range actually depends on alpha. Everything else is fixed. So because alpha is the angle of projection on the inclined plane angle was theta. Theta doesn't change. Theta was fixed because it is given in the problem that is the inclination of the inclined plane, whereas alpha is my angle of projection. So I have to basically find out maximum range with respect to alpha. So what is the alpha on which my range is maximized, right? So I should do dr by d alpha is equal to 0 for maximum range. This is first derivative to find maximum minima in terms of the variable alpha. So everything that is constant I will keep outside, 2v square by g cos square theta outside. And now I'll differentiate this part. So that will be cos alpha, cos theta plus alpha, plus sine alpha into cos of this. So that is minus sine theta plus alpha. This is the derivative. So this becomes actually simply cos of alpha plus theta plus alpha. This is cos minus sine, which is again the same formula. So this is equal to 0. So that means cos of theta plus 2 alpha must be equal to 0. That can happen when theta plus 2 alpha is equal to pi by 2. So therefore we get the situation that alpha must be pi by 4 minus theta by 2, which is basically 45 degree minus theta by 2. That is your alpha that is required for you to be able to get maximum range. Now, if we put this alpha in the formula here, formula for the range here, we should get the answer. So let's find out the maximum range by putting alpha here into the range formula. Okay. So let's see. Okay. So range will become 2v square by g cos square theta sine 45 minus theta by 2 multiplied by cos 45 minus theta by 2 plus theta. So it becomes 45 plus theta by 2, right? So if you simplify this, it is 1 by root 2 cos theta minus 1 by root 2 sine cos theta by 2 minus 1 by root 2 sine theta by 2. And this is 1 by root 2 cos theta by 2 plus 1 by minus 1 by root 2 minus 1 by root 2 sine theta by 2, right? Sine 45 cos minus cos 45 sine. Yeah, this is correct. So this is just a whole square of the same thing. So you get 1 by 2 cos square theta by 2 plus 1 by 2 sine square theta by 2 minus 2 into 1 by root 2 into 1 by root 2. So 2 into 1 by 2 sine theta by 2 cos theta by 2, right? So this is just half minus, you can write it as half into 2 sine theta by 2 cos theta by 2, which is simply sine theta. So you get finally after simplifying this part is becoming half minus half sine theta. So half will cancel with this, and so you'll get v square by g cos square theta into 1 minus sine theta, right? And that expression can be simplified further. V square 1 minus sine theta by g cos square can be written as 1 minus sine square theta. So your final answer for maximum range along the incline comes out to be v square by g into 1 by 1 plus sine theta. So v square by g into 1 plus sine theta. That is your final maximum range. So notice how we solved the question. The important thing is not remember the answer. The important thing is to understand what we did while solving. So we have understood basically regular projectile motion as one-dimensional acceleration and constant motion in one direction, right? So there is one direction where there is Vy is changing because of g, and one direction where there is constant velocity. In this case, you had two velocity components and two acceleration components, one like this, g sine theta, and one like this, right? So put your y and x like this and think about what happens here. So it is the same projectile motion except g has been replaced by g cos theta, and there is an extra x acceleration of g sine theta, and velocity has two components. So every formula that worked there will work here except the x range formula, which will now be x is equal to ut uxt minus g sine minus half at square. So minus half into g sine alpha into t square. This will be your range formula. And vertical velocity time of flight will be simply 2 vy by g in y, right? So that will be 2 v sine alpha by g cos theta. So time of flight will be this, and you put this time of flight in this expression, you will get the range value. I hope you understood the projectile motion clearly and how we are doing this. Uh, Hopefully this video has clarified certain doubts that you might have had about kinematics. I will come back with fresh videos and we'll probably go ahead in the theory of the classical physics course as we go forward. See you next time. I hope you learned something from this video.